Hello everyone, so we now proceed with our next topic. So our topic today is concerns about the numerical differentiation. No? So we're now on chapter 4. And in this chapter, this deals with the approximate derivatives of an actual function upon applying an interpolation formula in determining the approximating function. No? Objective are as follows. We have solve the approximate derivatives of an actual function. No? So that is our concern in this chapter. Okay, so take note that approximate derivatives only, no, of an actual function. So we will not deal with the exact derivatives of the actual function, no. So this is still related to chapter 3, no, polynomial approximation and interpolations. So derivatives of an approximating function applying an interpolation formula like the forward Gregory-Newton interpolation formula. So this is the forward Gregory-Newton interpolation formula. Now in this case, given this formula, we are to derive the derivative of an approximating function. Okay, so this is the approximating function now. Okay, applying the forward Gregory-Newton interpolation formula. And we take the derivative of this approximating function. Okay, so we'll derive it. So since x equals to x sub 0 plus rh, as I have introduced in the past, we can replace x by x sub 0 plus rh. Okay, so r here is the new variable. We have the x variable and we have a new variable r. So in terms of r, what will be our function? So this function is approximately equal to f sub 0 plus r delta f sub 0 and so forth. So let's take the first derivative with respect to r of both sides of the equation. So since our new variable is r, okay, we take the derivative with respect to r. Okay, so we take the derivative of f of x with respect to r. So taking the derivative of both sides of the forward Gregory-Newton interpolation formula, we have this. And then we simplify. Okay, we simplify r multiplied by r minus 1. We get r squared minus r. R multiplied by r minus 1 times r minus 2. We obtain r cubed minus 3r squared plus 2r. So why do we do this? So because it can be we can easily find the derivative if it is expressed this way. Okay, so we express it this way. We are to multiply the factors r minus 1, r minus 2. And then we have r minus 1, r minus 2, r minus 3. Then multiplied, we obtain r to the fourth power minus 6r cubed plus 11r squared minus 6r. Now, take note, it's not that easy to take the derivative of both sides of the equation. Okay, it's not that easy. So we introduce dx over dx. So we multiply the derivative of the function with respect to r by dx over dx. We know dx over dx is 1. Okay, so we will introduce that dx over dx on the left side of the equation for the right side, we simply take now the derivative. No, so it is now we can now easily obtain the derivative since r minus 1 is expressed in terms of r squared minus r and the likes r minus 1, r minus 2, r cubed minus 3 r squared plus 2 4 plus 2r and so forth. No, so with that, so the derivative of the function f sub 0, so take note f sub 0 is a constant. Okay, that is a constant, f sub 0. Therefore, the derivative of that constant is 0. That's why it does not appear anymore here. It's missing. For the derivative of r delta f sub 0 with respect to r, delta f sub 0 is a constant. So the derivative of r with respect to r is 1. So we get delta f sub 0. For the derivative of r squared minus r over 2 factorial multiplied by delta squared f sub 0, since delta squared f sub 0 and 2 factorial are constants, we simply take the derivative of r squared minus r. We obtain 2r minus 1. Okay? And then, same as this. This will retain. Then we take the derivative of the numerator, r cubed minus 3r squared plus 2r. We get 3r squared minus 6r plus 2. And then, considering the fourth term, or should I say the fifth term. So this is the fifth term. Okay, so this will be retained. Okay, and then we will take the derivative of the numerator. Then we will get this. So that's it. So we continue. Alright, so after that, so this is the previous solution, no? And in this case, naulit lang? Okay, sorry, naulit lang. Okay. So we now proceed. I don't know, hindi siya naulit. Hindi siya naulit. So as you notice here, dx and dr can be interchanged. No? So we can express this in terms of d over dx instead of d over dr, provided we have a dx over dx here. Okay, they can be interchanged. No? So d over dx of f of x, and this will now be multiplied by dx over dr. Okay, now recall that the simplified form of d over dx of f of x is simply f prime of x. That's the simplified form. The first derivative of the function with respect to x is f prime of x. So we have now f prime of x multiplied by d over dr of x. What is x? X sub 0 plus rh. Okay? So we proceed, no? So we have here, so what is the derivative of x sub 0 plus rh? So the derivative is x sub 0 is, the derivative of x sub 0 is 0 because it is a constant. H is also a constant. R is the variable. So therefore, we have h. The derivative with respect to r of xo plus rh is simply h. No? Because the derivative of r with respect to r is 1. Multiplied by h, we get h. Okay? For x sub 0, that is 0. Okay? So that's the simplified form, h. Then, so h will now be multiplied by f prime of x. So we have h multiplied by f prime of x. And then on the right side of the equation, it will retain, it will be retained. Okay. Now, this is we consider this as our first equation, the equation above. So we had obtained hf prime of x. Okay. Now, we take the second derivative of both sides of the equation with respect to r. So what will happen? So d over dr of hf prime of x, okay, approximately d over dr of this expression. So we have, so again, it's not that easy to obtain f double prime of x. It's not that easy to obtain f double prime of x. So to obtain f double prime of x, we introduce another dx over dx on the left side of the equation. So we multiply this derivative by dx over dx, okay, to obtain f double prime of x. So what is, so we can now simplify. So we have here, we can interchange the position of dr and dx in the denominator of both fractions, d over dr and dx over dx, no? So d over dr, dx over dx. We can interchange the position, that's why we have d over dx of hf prime of x multiplied by dx over dr. So approximately equal to d over dr of the expression here. So we know that h is a constant, and when we take the derivative of the first derivative with respect to x, that will be the second derivative. So that's why we have now h, okay, so h can be written on the left side of d over dx, okay, h can be written at the left side of d over dx. So this is now the simplified form, h d over dx of f prime of x multiplied by dx over dr. Then we take the derivative of the right side of the equation. So delta f sub 0 is, the derivative of it is 0 because it is a constant that can be found, okay, in the difference table now, in the forward difference table, okay. So we have 2r minus 1 delta squared f sub 0 over 2 factorial, okay. So the first, these are constants, right? And what is the derivative of 2r minus 1? That is simply 2. 2 over 2 factorial of delta squared f sub 0. So this is 1. So we have delta squared f sub 0. And then we have here the derivative of 3r squared minus 6r plus 2. So that is 6r minus 6 over 3 factorial multiplied by delta cube f sub 0. Then we have the derivative of 4r cubed minus 18r squared plus 2r minus 6. So we obtain 12r squared minus 36r plus 22. And since these are constants, this will just be retained. Okay, so we proceed. So as you notice, the simplified form of d over dx of f prime of x is simply f double prime of x. Okay? So then x is x sub 0 plus rh. So we take the derivative of that. So on the right hand side of the equation, we'll just copy, okay, what is written above. So we have now, so the derivative with respect to r of x sub 0 plus rh is simply h. So this is simply h. Because this is a constant, the derivative is 0. R is the variable. The derivative is 1 multiplied by h is simply h. So this is now h. Multiplied by h, we get h squared. Okay. And then, so we have now h squared multiplied by f double prime of x. Alright. Now, so we now obtained f double prime of x. It's now time to obtain f triple prime of x. So we take the derivative with respect to r, both sides of the equation. So we have, okay, so following the procedure, no, the previous procedures in finding the first derivative and the second derivative. So we will have this equation now for finding the third derivative. So we have h cubed multiplied by f triple prime of x approximately equal to delta cubed f sub 0 plus 24r minus 36 over 4 factorial multiplied by delta to the fourth f sub 0 and so forth. No? And then if we take the fourth derivative with respect to r, both sides of the equation, we'll arrive with this equation. H to the fourth, okay, multiplied by the fourth derivative of the function, okay, which is approximately equal to delta to the fourth f sub 0 and so forth. Okay, so that's it. So take note, when we have derivative, so for f, we introduce a number, okay, so this is a symbol for derivative, no, parenthesis, open parenthesis, number, then close parenthesis. That is a symbol for derivative of the function. And then we have here the summary. Okay, considering the first derivative of the function, we have this equation. Second derivative, we have this equation. Third derivative and fourth derivative. Okay, so we proceed. So in this case, take note, we we use the forward Grigori-Newton interpolation formula so that we can able to obtain the first derivative, the second derivative, third derivative, fourth derivative of the function. Okay? So at r equals to 0, okay, x equals to x sub 0. So at r equals to 0, x equals to x sub 0. So take note that r is equals to x minus x sub 0 over h. Okay, this is the formula. When r is, so in that case, that is x sub 0 plus rh. If r is 0, the two are equal. X equals to x sub 0. Okay? So this is now the result. F of x sub 0 equals to f sub 0. Okay? So that will be the result. We know that f of x is f of x sub 0 plus rh. If r is 0, f of x is simply equal to f of x sub 0. And f of x sub 0 can be simplified as f sub 0. Okay, and then we take the first derivative at x equals to x sub 0, which is a specific value of x. So, and then we have here delta f sub 0. So this is in the, this is written in the summary. Okay, so let me show you. So this is f prime of x, delta f sub 0 plus 2r minus 1 over 2 factorial delta squared f sub 0 and so forth all over h. So applying this, we obtain this. Okay, so f prime of x sub 0 delta f sub 0 minus 1 over 2 factorial delta squared f sub 0 and so forth. Okay, because r is 0, so this will now be derived. Okay, these are derived from the previous slide. No. Okay, so taking r to be 0, we derive the equation. So with that, we consider the second derivative of the function at x equals to x sub 0. So we have this derived equation considering r equals to 0. Then considering the third derivative at x equals x sub 0, we have this equation. Then less the fourth derivative at x equals x sub 0, we have this equation also. Okay, so that's it. So let's answer a problem regarding this topic. Applying the forward Gregory-Newton formula, find the first and second derivatives of square root of x at x equals 2.50 from the table, considering the following. A. The first two terms of both first and second derivatives. B. The first three terms of both first and second derivatives. C. The first four terms of both first and second derivatives. D. All terms of both first and second derivatives. E. Applying the exact first and second derivative formulas for square root of x. Which among the results in A, B, C, and D are the best approximations for the first derivative and second derivative of square root of x at x equals to 2.50. So here's the table. Okay, let us first answer letter A. Solution. So first thing to do is we have to construct the forward difference table, and you know how to construct it, right? I have already taught you on how to construct such. So, and then after constructing the forward difference table, so from the forward Gregory-Newton formula, okay, considering all six terms based on the forward difference table, okay, so we have this equation, okay, and then obtaining the first derivative of both sides of the equation, we have this simplified equation. Okay, obtaining the second derivative of both sides of the equation, we have this equation. Obtaining the, okay, since x equals to x sub 0 plus rh, then r equals to x minus x sub 0 over h, where h equals to x sub k plus 1 minus x sub k. Okay, so at x equals to 2.50, x sub 0 is equals to 2.50. Okay, so let us see. So in the problem, we have to find the first and second derivatives of square root of x at x equals to 2.50, right? And 2.50 is x sub 0. This is x sub 0. Okay? So, let us continue. Okay? So, we have here h equals to x sub 1 minus x sub 0. So, we have 2.55. So, x sub 1 minus x sub 0. So, the tabular interval. Okay? 2.55 minus 2.50. Okay? So, we get 0.05. Okay? We get 0.05. Right? 2.55 minus 2.50. So this is age. This is age. So this is our tabular interval. No? Okay, which is 0.05. And with that, we solve for r x minus x sub 0 over h. We get 0. We consider the first two terms of both f prime of x and f double prime of x. Okay, so at x equals 2.50, okay, we are to obtain f prime of 2.50. Okay, so which is the first derivative at x equals 2.50. So we know that h is 0.05. So from the forward difference table, we have 0.01573. R is 0 as obtained in the previous slide. Delta squared f sub 0 is negative 0.00015 as seen in the forward difference table. Okay, and we will get an answer of 0.3161, which is the approximate derivative of square root of x at x equals 2.50. Then we consider finding the second derivative at x equals 2.50. Okay, and we will have an answer of negative 0.0600. So this is now the approximate second derivative of square root of x at x equals 2.50. Considering the first three terms, okay, so that is for letter A. So this is for letter A. We obtained the approximate derivatives, the approximate first and second derivatives of square root of x at x equals 2.50, considering the first two terms only. Okay? Considering the first two terms only. For letter B, we now consider the first three terms of both f prime of x and f double prime of x. So first term, second term, third term. Okay? In the previous slide, we only considered the first two terms, no? The first two terms. Okay? So this time, the first three terms. So considering the first three terms, at x equals 2.50, okay, we have this, uh, s- uh, we have this now, this solution, and we will have an answer of what? 0.3161. So that, let's compare. Are they the same as the previous slide for letter A? 0.3161. Yes, they are the same. Considering the first two terms, having four decimal places for our final answer, they are the same. But extending the number of decimal places, okay, they're really not equal. Okay, if we extend the number of decimal places, okay, beyond 0.3161, beyond four decimal places. Okay, so with that, we continue. For the second derivative, Okay, considering the first three terms, okay, considering the first three terms, we will obtain an answer of negative 0.563. Let us compare in our previous answer for f the it's not exactly the same, right? There is some variation. Okay, it's not exactly the same. Considering for decimal places for the final answer of the second derivative of square root of x at x equals 2.50, they're not equal to 4 decimal places. Okay, so later we will compare it with the actual value of the derivative at x equals 2.50. Okay, so we will compare. So in here we considered the first three terms of the of f prime of x and f double prime of x. In the previous slide, letter A, we considered the first two terms. So let's see. For letter C, what is being considered? Considering the first four terms. Okay, so we have the first term, the second term, the third term, and the last term. So we'll obtain an answer of 0.3161. Let's see. Is it the same? Yes. Okay. So considering for decimal places, the answer is the same. No? So how about for f double prime of x? What will be our answer? It's negative 0.0463. Oh, what happened? So let's see. So it's not the same. It's not also the same. Okay. So this is an approximation considering the first four terms. In letter B, in letter B, we have the approximation considering the first three terms. For letter A, we have the approximation of the second derivative considering the first two terms. Now, considering the actual value of f double prime of x at x equals 2.50, which is the nearest answer for those approximations. So we will verify. We will discover. Okay, so I'm done with this. We now proceed with letter D. Considering all terms of both f prime of x and f double prime of x. Okay, so considering all terms, we have, so this is the equation. Okay, considering all terms. So because in our difference table, it's up to delta to the fifth f to f sub k. Okay, so with that, our forward Gregorian Newton interpolation formula will be until there. No? Okay, will be until delta to the fifth f sub 0. Okay, and then we have, okay, so substituting the values for h, for r, for delta f sub 0, for e, okay, so we will obtain an answer of 0.3159. So as you notice, it's no longer equal to C, no? To letter C. So 3159. Considering all the decimal places, considering all the terms of the forward Gregorian Newton, okay, for we have 0.3159 considering all terms. okay, which is the first five terms, okay, but which is nearer to the actual answer of the first derivative of square root of x. We'll determine that no later. So we have f double prime of x, okay. Substituting the values, we get negative 0.0463. Considering all the terms of the second derivative of f. Okay, so we have so as you notice, for letter C, negative 0.0463 second derivative. For letter D, negative 0.0463. They are what? Are they equal? Yes, they are equal, right? Negative 0.0463, negative 0.0463. Okay, they are equal to 4 decimal places. Okay, considering the first four terms, okay, for letter C, considering the first four terms, delta squared f sub 0, delta cubed f sub 0, delta to the fourth f sub 0, delta to the fifth f sub 0. Okay, so which is the same as the previous, letter D. Delta squared f sub 0, delta cubed, delta to the fourth, delta to the fifth. That's why they are the same. So we considered all terms. So considering all terms for the second derivative, those all terms are only 4. Okay? Which is the same for letter C. That's why they are equal. Okay? Alright, let us determine the actual values of f prime of 2.50 and f double prime of 2.50. So f prime of 2.50, that is the first derivative of the function with respect to x at x equals 2.50. So f of x is simply square root of x. We take the derivative. From calculus 1, we have 1 over 2 square root of x as the first derivative. And we substitute 2.50 for the value of x. We will obtain an answer of 0.3162. Excuse me. So which is nearer then to our answer for the first derivative? Considering all terms, 3159, right? This is 3162, 0.3162. Let's see. For A, B, and C, 3161. So therefore, our answers for A, B, and C, okay, are nearest to the actual answer. No? Okay? 0.3162. For the second derivative, negative 0.0632 as our answer. So how did we arrive at that? So f double prime of 2.50 equal to the second derivative with respect to x of the function at x equals to 0.50. So we take the second derivative of square root of x at x equals to 0.50. So the second derivative can be expressed in terms of the first derivative of the first derivative of square root of x. The first derivative of the first derivative is simply the second derivative. No? So with that, we have this. We take first the first derivative of the function. Okay. where the function is equals to square root of x. Then we substitute x equals 2.50. So the derivative is 1 over 2 square root of x. So we differentiate again. Okay, applying calculus. No? Applying calculus 1, the derivative is negative 1 over 4 square root of x cubed. So let us check whether it is correct. So what's the derivative with respect to x of 1 over 2 square root of x? So we know that this is, so 1 over 2 can be written as 1 half times the derivative with respect to x of square root of x can be written as x to the negative 1 half. Okay, so 1 half of negative 1 half times x minus 1 negative 3 halves. There, you have negative 1 over 4 x to the power of 3 halves. And what is that? Negative 1 over 4 square root of x cubed. There. That's why we get negative 1 over 4 square root of x cubed. And then we substitute the value of x of 2.50. We will now have our answer of negative 0.0632. So which is nearer? Which is the nearest among the four values we obtained? What is it again? Negative 0.0632. Okay, this one. Okay, negative 0.0632. Let us see letter A. Okay, this is the nearest answer, right? This is the nearest approximation to the actual value of the second derivative of the function at x equals 2.50, right? So that is the nearest. So considering the first two terms, okay, is the nearest in this situation, okay, to the actual value of the second derivative at x equals 2.50. Okay, comparing the actual values to the approximated values of f prime of 2.50, okay, and f double prime of 2.50, it is observed that the best approximated values are those results obtained in A. Okay, so that will be our answer, no? So what is being asked again in letter A? For letter A, applying the exact first and second derivative formulas for square root of x, which among the results in A, B, C, and D are the best approximation for the first and second derivative of square root of x. So it's letter A, no? It's the answers obtained in A, no? Are the best approximations for the first and second derivatives of square root of x. Sa first derivative, yung A, B, and C, pare-pareho. Sa second derivative, ang best approximation ay letter A. Therefore, A ang ating best approximation sa parehong first and second derivative. So that is our answer. So we can proceed. Okay? Are those results obtained in A? Okay? So here's the lab activity that you will do. No? Simulate the solution of the given problem using Excel such that the correct value of the first and second derivative of square root of x is obtained for any value of x between 2.50 and 2.75. So So here's the problem. So this is the previous problem. You will simulate it now. So to give you an idea, no. So I have here my presentation, my Excel file presentation. So as you notice, so this is the problem. Find the first and second derivatives of square root of x at x equals to 0.5 from the table. But actually, this is not exactly the same as this for lab activity 14. So you will perform some adjustment. No, okay. So the instruction is not exactly the same. Okay, find the first and second derivatives. Okay, so with that, so this is what you will do. So you will provide me a difference table. Okay, this is just easy, right, to do the difference table. Then you have the formulas, the formulas for f of x, applying the forward Gregory Newton, f double prime of x, no, f double prime, okay, f prime of x, f double prime, okay, and then and then we have here, so we're going to determine the first derivative at x equals 2.5, where x of 0 is 2.5, right? X of 0 is 2.5, right? So we can able, then we have h equals 0.05, no? We have h equals 0.05, then r then is 0 as computed, no? Then we will have f prime of x. So this is the equation, okay, the manner and how to obtain the answer. So we get 31593 considering 5 decimals. So what you will do here is you only consider 4 decimal places. It's so as I have told you, it's not exactly the same, okay, as the previous, but okay. Let me convert. We can convert that easily to 4 decimal places. Okay, this is just, let us adjust. Okay, there. So about this, okay, okay. So we have that. So considering all of the terms, these are the answers. F prime of x, f double prime. The first two terms, we have these answers. Then three terms, 3161, negative 0.0563. Four terms, 3.3161, negative 0.0463. Exact value, so for the exact value, okay, so we have 3162 and negative 0.0632, okay, for the exact values. Alright, so that this is the one that you will do, no? So I hope you get it, no? And then you have a conclusion here. Therefore, the first two terms are preferable. So take note, okay, for any value of x between 2.50 and 2.75. So that means I can edit, no? So I can edit 2.50. Let's say I have 2.6. X is 2.6. So we'll have an R value. And these are the f prime of x values. F double prime, F prime, F double prime. This is the actual answer. Okay, this is the actual answer. So there is square root, diba? Square root of x cubed. Square root of x, right? Okay, so this is our the actual values. So which is preferable? Two terms? Four terms? No? Okay. So which is preferable? First two terms? Let's see. This is negative 0.06. Find out negative 0.0596. Okay, which is nearest? First two terms. Okay, panalo pa rin yung sa first two terms. No? 0.3101. Ayun. Okay, so first two terms pa rin. O kaya isagad na natin 2.75. X is 2.75. R is 5. Okay, preferable pa rin yung first two terms, no? First two terms pa rin. 2.75. So 3011, okay. 3015 is the answer. So nearest. Ito yung preferable. Ay, hindi. 3011. Ito pa rin, no? Tie sila ng first three terms. Pagdating sa second derivative, negative 0.0548. Ito pa rin ang panalo. First two terms pa rin. First two terms. So that's it, no? I hope you get it, no? So ganyan yung gagawin nyo. Okay? So that's all. Sige. Good day, everyone.